Hello, Elixar here with another DevBlog. The topic du jour is, what's taking so long? The answer? Systems. Lots and lots of systems. A complex game requires a network of code that handles everything that needs to be done, from startup and load to save and shutdown. These systems form the scaffolding of the Satus game engine on which everything else will be built. Now, without getting too nitty with the gritty details, let's look at what one will need to do to build the foundation of Satus from scratch. Step 1. Choose a game engine. If you don't want to write your complete game from scratch, it's always wise to utilize game engines that already exist. There are a ton out there. Among them, BuildBox, Construct, Corona, CryEngine, FlowLab, GameMaker, Godot, RPG Maker, Unity, Unreal, and many, many more. Once you've tested them all out, now you'll need to invest time to master the engine. You chose Unity to develop Satus? Great! See you when you've climbed the learning curve.
One eternity later.
Step 2. Determine the workflow. Your logic needs a workflow from start to finish. When the game starts and the world loads, what happens next? You need to generate the world data, show the world data, move around the world. Good job! Now you have a prototype. It's slow, clunky, and won't be able to manage any system you wanted to build on it, but at least it's something. Now comes the real work. You've unlocked naive optimism. Step 3. Performance enhancement. It takes 100 milliseconds to load a chunk? Great! This means the game runs at 10 frames per second. You must now learn to use multi-threading in Unity's new job system. You can't pass regular arrays to the job system? Congratulations! Now you must learn native lists and how to work with unmanaged memory. What is unmanaged memory? Variables that don't go through Unity's and C-Sharp's typical garbage collection system. You must remember to dispose all native data or you'll have memory leaks. Good luck! You've unlocked frustrating lack of documentation. Step 4. Level of detail. You want your game to really pop? Let's make the world render as far as the eye can see. To do this, you need to generate even more world data, meshes, and do some complicated math so that the terrain transitions smoothly from higher to lower detail. After many, many attempts, you finally got it working. Great! Now generation is really, really slow. +1 coding skills, +1 concussion from banging your head on the wall. Step 5. Map editor. So you have this idea that you want the player to be able to edit the world before starting a new game. You think you're smart and want to kill 2 bugs with 1 swap, so you decide to make a map editor and use that data as a template to speed up world generation. Congratulations! It looks nice. Too bad it took 2 months to implement. Step 6. Multiplayer. Now you really want multiplayer included. For this to work, you need to split the code in twain. The generation and loading into a server assembly, and the meshing, rendering, and display into the client side. That completed, you must now make it so that the 2 sides of the program can talk to each other. You must now learn networking. Step 7. Bandwidth. So now that you have all the data going between a network connection, congratulations, you've unlocked a new problem. Bottleneck. All of those data packets aren't small, and sending them one at a time on the main thread is slowing the game. You must now learn native networking to send large data packets asynchronously. Congrats! You've lost another 2 months. Step 8. Lag spikes. So everything seems to be loading well and you have good communication. Great! Now the player needs to move and... oops! Lag spikes! You must now refactor the generation and render code to reduce the spikes. +1 coding skills, -1 social life. Step 9. Memory leaks. So now that everything seems to be working well and you have a lot of unmanaged variables peppered throughout your code, you decide to check your memory usage. Congrats, you just coded a memory hog. You must now painfully track down every memory leak you created. This will be both painful and slow. Unlocks questioning life's choices. Step 10. Steam integration. Now that you got a solid base, you want to make sure that all the networking works with your game seller of choice. You've chosen Steam? Great. Here's a new code library to use, Steamworks. Let's shoehorn that in there. What can go wrong? Unlocks networking nightmare. Step 11. Basic awareness. Now that you have a world that is working well, you need a system that can tell you where in the world the mouse is pointing. You need a collider on 10,000 terrain meshes? Good luck tanking your performance again. Instead, want to make your own raycasting system to speed things up? Congratulations! This unlocks integrating a completely new native library to run native raycast functions, learning a new coding language, Rust. Step 12. Simplification. Now that you have all these systems, you realize that a lot of old code overlaps and can be simplified. You decide to make things simpler by consolidating some code. This shouldn't take long. +1 refactor, minus significantly more time than expected. Step 13. More memory leaks. Your refactoring went great. Unlocks more memory leaks.
Go!
Step 14. Build a dedicated server. Want to build a dedicated server to test how the world loads on multiple instances of the application? That won't be easy. You must learn how to strip out the code, shaders, assets, and logic you don't need on the server, while still making the code compile for the server and client versions. +1 networking, +1 new hair color. Gray.
Get off my lawn!
Step 15. Hosting server. Want to host that dedicated server somewhere? Yeah, that system needs build as well. You must now learn server management. Congratulations, you have now successfully formed the scaffolding on which the game of Satus will be built. This is what it looks like. +1 happy feeling. All that's left now is to build every system into the game. -1 happy feeling, +1 sad feeling. Now that you've made it this far, you're left with a choice. Do you continue coding Satus, give up and try an easier career? You've got 10 seconds. Decide.